My name is Charles Shirer. I go by the name of the BSD Bandit. Today we're going to be talking about abusing API security. So a little bit about myself. I've been in this industry for over 20-something years. Class of 2003 from Virginia State University. Security is something that I've always loved, whether it was just computers before it even had any type of name. So I'm a Unix geek, still to this day, a lover of BSD, huge fan of retro gaming, as you can see in the screen here, hence why I have the Ice Climber t-shirt on today. Reason being because it's always moving forward, it's always a climb up to the next level. So hence why I just chose that shirt and that pic today with the Treasure Troll and Bomberman. Also a husband and a father. I love hanging out, getting into nature and everything else. So here we go. So just a little backstory. The reason I wanted to do the talk here today related to APIs. So a couple of years ago, I did get started in just basic API penetration testing and just learning the basics of like REST APIs. But for several months, I wanted to just kind of like dig in deeper because APIs is the way where we are now. This is how we really communicate with the internet. 90% of that traffic is making some type of API call, whether it's REST, and forgive me, SOAP, gRPC, and SOAP is an honorable mention, by the way, but gRPC and GraphQL. So before we get into any type of attacks or anything else, we need to understand what GraphQL is and how does it work? Because as a hacker, in order for you to hack anything, you have to understand how things work. Because if you don't understand how things work, you're not going to be able to hack anything. So with GraphQL, it's really just a query language. That's it. It really that simple. Like you can gather information from a database, even operating systems. It's an attractive feature for developers because of the fact that it gives you the exact information that you're actually looking for and not anything more. The issue that a lot of developers are running into with REST APIs is the fact that you can ask for, say, like a username, a password, but you wind up getting not only a username, a password, someone's hat, my t-shirt, SSH, all these different configurations that you might get back that you had no use for. With GraphQL, if you ask for a username and a password, that's exactly what you get, nothing more, and it saves on the bandwidth. So that's what makes it attractive to developers in general. A lot of cool things about it is the fact that you can actually, when you send a query, it goes up against the schema. The schema takes a look at it to see if you have the proper permissions or whatnot, and then it gets you the resource and then sends it back out from the database or the operating system, or depends on how you have it configured. Now, that's the good stuff about GraphQL. What's interesting about it, and we're going to get into the structure here in a second, the problem with GraphQL is the fact that a lot of things that we will use to abuse this API are considered just features to developers, which we'll get in here in a second. But what you're looking at here now is understanding how the structure of GraphQL is. So of course you have your schema. We're going to be getting into queries. And all a query is, think of a query as you're just extracting the information. You're not modifying it or anything else. You're just reading the information that the API sends back to you from your request. Now the mutation. Mutation, now you can look at it from a standpoint of, hey, I'm able to modify data. And what I mean by that is this. When you get a GraphQL mutation, that allows you, for example, to create a user account or delete some data or update a system. Depends on how the GraphQL is actually configured. And then you have your fields and you have your objects. As you can see here, we have a user object, but within that user object, you have your ID, the name, the email address, and your post. And same thing with the other post object is your ID and your title. And this is how GraphQL is actually structured as a whole. And you'll see here in a moment. All right. Now that we've gotten the meat and the potatoes out the way, we understand how GraphQL is, I'm going to take you step by step on the eyes of a penetration tester. So when you walk in or you gain access to maybe a web app, whether it's internal or external, because GraphQL is not just external. There's a lot of places that actually use it internally as well too. Now we're going to get to the recon phase. Now, there's many different ways of trying to figure out if a web application is actually using GraphQL. And you always want to assume whenever you see any type of application, whether it's web, external or internal, you always want to assume there's an API. So a lot of times what I would do when I'm going up against a web application, of course, to do the traditional Nmap scan to see what ports are actually open, actually go to the particular ports as it's scanning. As you can see here in this case, I went to port like 5013, which is just like an application just to see what's actually out there and what the interface looks like. Now, once I've got the information, I say, okay, this is a web application. What else can I get from this application? Let me check to see if it does have GraphQL. Now, the cool part about Nmap, it actually has a built-in script that you can actually check for that to see whether or not GraphQL actually exists. This is one method of doing recon when you're looking for a GraphQL API. Now, it does some extra checks to see if it's vulnerable or whatnot. You can do that in many other ways as well too, but this is just one of the ways if you're not familiar. You can also use this with just built-in Nmap on your Kali or Arch Linux or whatever operating system that you're actually using. Here's another way to actually, once you've got the recon from Nmap, you can also do this with GraphWolf. Now, GraphWolf is based off of, I don't know if you guys use the tool WAFWolf. It's kind of pretty much the same thing, right? But it's just designed specifically for GraphQL. Now, the cool part about this is not only does it give you the endpoints that you're looking for, which there's many. Now, in this case, you see there's like just GraphQL. That's not always going to be the case. A lot of times you might see V1 GraphQL. You might see that the developers renamed it to probably Graph or a different name. You're not going to know unless you're actually attacking the application. But there's a lot of common endpoints that are built into a lot of these tools and word lists, especially sec lists. Now, the cool part about that is like you can take that, and as time goes on, of course, you can add more to your word list. In this case, I just wanted to give you a basics on what GraphWolf looks like, and what you're seeing here is just a fingerprint. Now, the cool part about this as well too, you can see where it not only discovers that it's vulnerable, but it gives you the actual engine of GraphQL. Now, in this case, there's a cool GitHub called Threat Matrix, which I'm going to show you here. The cool part about this GitHub with Threat Matrix, now that you know that it's GraphQL, we now know that it's running a Python-related version of GraphQL, which with GraphQL, there's different programming languages that it's written in. So it could be Rust, it could be Scala, it could be Java. There's a Java-based one as well. Once you know that information, this is the best resource to see what the default configurations are. Now, by no means, this may not be the case for all applications, but majority of the applications that I've run into so far have had introspection, and I'll explain what introspection is in a second, has had introspection enabled by default. Now, what introspection is, it allows you to get the entire schema of GraphQL, which is interesting enough. When doing some research, I'm like, okay, I'm like, this is not considered a vulnerability. Even on the mailing list, asking questions to other developers that actually work with GraphQL every day, and they're saying this is more so a feature. GraphQL doesn't provide you with any type of authentication. That's something that has to be coded within itself. That's something you have to code. That's something you have to create. GraphQL also, there's been issues when if you disable introspection, it can cause issues with the application. That's why with developers, a lot of them use the staging process. So they'll have a staging environment and then they have the production environment. I've run into situations where they've disabled introspection in the production environment, but had it enabled in the staging environment and the development environment. So now what you're looking at here is just more so, we're still in the recon phase. So it's just more so looking at like the endpoint discovery. You can find GraphQL simply by browsing through the application, making it proxy through burp, and it'll give you just the common endpoints, which is also a good thing. That's another way of actually finding out the different endpoints or whatnot and see what you're actually working with. The cool part about burp is you're actually seeing the request and the response, which kind of gives you a little bit more detail about what's going on in the background there. What you see in this particular screenshot with that particular query, and I'll send the code that I use as a reference. So what this does, it actually parses the output from that particular input, and it gives me the information on what it's doing. If it's a mutation, if it's a query, or if you get like, in this case, it's saying get paste or whatnot, but it gives you the type of query that you're looking at in burp. So, but I'll have that sent out at the end of the presentation. Now, another part of the recon phase here, and this is one of my favorites. It's interesting. This is called GraphQL cop. Now, GraphQL cop, I use this. Think of GraphQL cop as the Nessus scanner for GraphQL. That's literally what it is. It just gives you a list of potential vulnerabilities. Now, whether or not they're false positives, that's something, of course, we never rely on a scanner. We always want to double check behind the scanner, make sure that what that scanner is producing is true. But GraphQL cop is a very good thing to use when you're doing the recon and enumeration phase to give you a lay of the landscape of what you're dealing with, what type of GraphQL, any type of vulnerabilities, and then you can go back and check whether or not the information is actually true. Now, let's get into the fun part. Like I said with introspection earlier. Introspection gives you the entire schema of the GraphQL API. So, which is pretty much, it's like having access to the keys of the kingdom within GraphQL. Now, what you see here, this is a particular query. You can, when you send that particular query, it gives you back a list of types. So with this particular query that I'm doing here, I'm just checking the schema for all types that are in that schema. That's what that query says. So, and as you can see in the response, it gives me a list of all the different types of objects that are in that particular schema of that application. Now, some developers, what they have done, in the event that they have disabled introspection, they pretty much monitor for this particular type of query as well too. So they'll monitor for schema in this sense. So the only other bypass that I've figured out so far in my research is actually creating a space between the schema. So you can so it's a couple of things. You can remove the underscore, the two underscores, and hit schema. And depending on the actual GraphQL environment, that might work. Now, another instance, what I've tried as well too, is keeping the underscores, but creating a space between schema and types. So that's another way of actually trying to see if you can, if they're monitoring for something and just blocking it, that's another way that you can actually it's pretty much like bypassing that particular defense. It's like if you're doing like cross-site scripting. Now, if you get these objects back, and it's great, you get some good information here, right? You're like, okay, I've got something, but it's not much. I need to know more. I need to know what this API is doing. What can I do with this information? So we get to do some more digging. Now, What you're looking at here is a case where the application has introspection enabled. And we're going to get to what to do in the event that it is disabled. So right now we're working from a perspective that this is enabled. So you're sending a query now, and I call this the hot guns. So you're sending it's like all hands on deck. You're sending everything at it. Give me everything. That's pretty much what you're telling the GraphQL API. Give me everything, all your mutations, all your queries, all your subscriptions. Give me everything. And if introspection is enabled, the feature is enabled, this is what you'll receive back in this particular example here. Now, once you've received that information, you take that information, and it's a pretty cool tool called GraphQL Voyager. Now, this is the website version, but I do have an internal VM that runs GraphQL Voyager. So you can run it on an internal VM. So if you're on like an internal assessment and you run into this, and you can have it on a VM, on a Kali VM or whatnot, or Linux just in general. I'm the weird one. I run it on FreeBSD, but that's a different story. But in this case here, look at GraphQL for the net pen testers. Look at GraphQL as GraphQL API's Voyager. Look at it as just nothing but Bloodhound for GraphQL, because you're mapping. This is the entire map of the entire schema. So we have a combination of system updates. Look what we got here. We got some cool queries here. We've got some system updates, diagnostics. You got your debugging. We got user accounts. And you see there's the me, the user object that has access to that user object. Then you have a situation where you have the paste query, and it looks like it has access to the public and a user agent, but then it also, you see an owner object here, and it has some more information there, like the ID and username. So it's pretty much like how you would look at Bloodhound, and you've got a map of the entire Active Directory and permissions and everything else. That's the same thing that you would look at when it comes to GraphQL. Now, the cool part is, now that you have this information, now this is where you can actually start to begin the attacks process, because you want to know what you want to go after. You already have all the information. You know what you're going to go after. Here's a juicy one, system debug. I mean, debugging gives more information, so I would definitely go after that one. Definitely user accounts. I would definitely go after, of course, system update, but that's for another story. Now, now you run into an application where the developers, and you're going to run into this eventually as well too, because as time goes on, developers are digging more into this and trying to figure out the security side of things when it comes to GraphQL. They have taken away our favorite toy, folks. No more introspection. It's disabled. And you only find that out when you try to dump the schema. And this is the message that you'll get back, clear as day. It's disabled. So now you think, okay, what do I do? Here's what you do. If you run into a situation where introspection is disabled, now you have to run into suggestions. It's like suggestion fields. Some people call it field fuzzing. Some people call it suggestion fuzzing. So this is another feature of GraphQL, by the way, too. This is not a vulnerability. So the cool part about GraphQL with suggestions, it gives you the information that you're looking for. Now, this is the manual way of actually putting together the schema, but I'll show you the automated way here in a second. Now, you see here, I purposely misspelled the username, and I added an extra E. And you see in the message, it's literally just saying, hey, did you mean username? I'm like, okay, cool. GraphQL, now I know that, okay, this API uses a username in some type of object or form. Same thing, you could do this with system as well. You could just literally pick a combination of different words, like maybe system. The words I usually use when I'm in this situation, I use system, I use debug, and I use, of course, username, and I use password. I'll just say pass and just see if that gives me the information that I'm looking for. So that kind of gives me a way of actually mapping this thing out, right? That's the manual way. which I wouldn't recommend because that'll take you forever, because some of these applications are huge. For the automated side, our friend Clairvoyance eschews the BSD logo at the top. Tell you I'm a fan of FreeBSD. So with GraphQL, there's a cool tool called Clairvoyance. Clairvoyance is just an automated way of actually fuzzing the suggestions in GraphQL. So what you're seeing here is it's taking the, and I'll give you the link to the word list. It's a specific word list that you should use with Clairvoyance so you can get the best results. Sec list is not it. It's something called like high vocabulary. So I'm gonna drop all this information so you guys will have it in your disposal. But this is the automated way of actually getting the schema information without having introspection enabled. Now, another thing, once you've gotten this information, right, and in this case, you can upload it, you can save the output to a JSON file. I usually save it to a JSON file. I don't go directly to the site because it's already disabled, so you have no option there. I wanted to point out, like in QL, like even if introspection is enabled, you can use burp in QL to just go directly to the endpoint, and it'll give you the schema that way as well too. What I just showed, the other ways I just showed you is just other ways of getting the same result. In QL, in this case, introspection is disabled, so just providing the URL does me no good. Hence why, from Clairvoyance, I actually saved it to the ccoutput.json. I saved the JSON file. You upload the JSON file, and you can analyze that JSON file, and that will give you a list of what the schema is. I actually like this method better because it gives you a clear-cut directions on how the API works. As you can see here, it gives you the mutations, and it puts it in folders for you. So kudos to whoever developed NQL. I love y'all. So they put it in nice folders. You got your mutations, you got your queries, and then if the GraphQL API is even larger, you'll see even more folders. You'll see even more information that you'll have to dig through. But this gives you a running start on what to do and what calls you can make, what information that you can extract, what information that you have access to. Now, what you're looking at here is a totally different GraphQL Voyager here now. So the ones you saw earlier was when introspection was enabled. This is a little bit less data. As you can see here, now it has a date and time, the dummy string. It's not going to get everything, but it gets you enough information to where you can still be dangerous. Now, as you can see here in this case, we have access to system update. We can make some system update calls. You can delete some information now. We got system diagnostics still. We still have access to users. And then as you can see here, look at this. We have access to IP addresses. You have access to like the public Boolean. You have access to owner objects. So you have access to some information, not all of it, but it's enough to be detrimental to pretty much compromising the GraphQL API in itself, and which you're going to see some demonstrations here soon, shortly. Now that we've got the recon, we've gotten through the enumeration, we know what our API does now, we know what GraphQL can do, we know what information that we have access to, what information we don't have access to. Whether introspection is disabled or not, we don't care because we have something that we can go off of and we can gain access to, right? Now, this particular attack, we're going to get to the attacks now. This particular attack, GraphQL batch query attack. So just going to show you an instance here. I use batch query attacks when I'm doing brute forcing of username and passwords within GraphQL. Now, what you're looking at here, I would not recommend because we're not in the business of denial of service, but with this particular batch here, so the cool part about this situation with this particular attack, it allows you to bypass the rate limit that the developer might have in place, because you can stuff all the queries into one, and that particular API will just see it as one big query, as opposed to many different queries, which pretty much affects rate limiting. And that's only if they have rate limiting enabled with GraphQL. GraphQL is pretty much like the bare bones. Now, in this case here, you see I'm using the system update object, which we have access to. We go back to, I just wanted to show you that real quick. You notice we have the system update, we have access to that, and that just requires just a string. There's like no extra information related to it. So knowing that I have access to system update, I can just run several system updates to eventually the server gives way. But that's nothing you want to do during testing. I wouldn't recommend it. I like being employed. So, brute forcing. This is what I usually use this particular attack for. So you can add as many queries as you want into one just to try to, and this is when you get like username and passwords, and I'll tie all this stuff here shortly as we go through some more attacks. But say you have access to the user accounts. You know you have access to the user account, you just don't know the password. So now let's test to see how strong the passwords really are. This would be the type of attack that you would use. Now you notice you see mutation instead of just query. Because again, now we're trying to guess a password. We're doing something here. We're not just reading anything. We're actually doing something. And that's why it's a mutation instead of a actual query. Reason being, with the mutation, you're trying to log in. That's the action that is trying to do with GraphQL here. And you can use you can try as many passwords as you want in one query. So until you can actually get the information. And again, this is now, if there's been some developers that have been pretty tricky with this as well too. So they're getting hip to this as well too. So don't be surprised if you run into some attacks and it kind of takes a little bit longer than expected to crack a password using like batch queries. Now, my favorite, I like this. This makes me smile when I see this. OS command injection attacks through GraphQL, by the way. Now, the cool part about this, again, we go back to our bloodhound. Well, I'll call it our graphhound in this case, right? So when you're attacking GraphQL, 90% of the time you will live in the Voyager, because the Voyager tells you exactly what's in the schema and what you have access to and what information that you're going to be using. In this case, I wanted to do some type of command injection. Now, here's what we have access to. System debugging. You can do system update, system diagnostics. So I chose system debug. It could be named something different depending on the application itself, because it might have a different function. Because developers might change it and say, you know what, to kind of throw us off here, we won't name it system debug. We could change it to something else and code it to be something else. So, but you always want to assume that this is something where you can do some type of injection. So what I wound up doing here, went back to my Voyager and say, okay, cool. I'm going to try to do some injection through system debug, just using, again, only the strings that it requires. So you can see here where it says system debug, all it asks for, it's just one argument, literally just one argument. So when you do that, here's what you get. So if you can see my query here, and what I did here was just more so, now the command inject, you can name that anything. That doesn't matter. That doesn't affect the query whatsoever. I could have named it Bandit and it would still work, right? So query, command inject, and then I just wanted to make it, put this on a new line using the system debug command. And again, it looks for that particular argument, right? So the argument, of course, now that's where I put Bandit, but, and I just wanted to do a uname -a, because that's like my favorite command to run when I'm testing for any type of OS command injection. And as you can see, what comes back is GraphQL. Now, you can also do this, what makes this particularly dangerous, right? So a couple of things. Suppose this was an internal application. We can make it even worse, right? Suppose this was an internal application. The next thing I'm going to try to see if this box is connected to a domain controller and start sifting my way through Active Directory. Let me see what I can get from there from a Linux box that's connected to a domain controller on an internal network. Because again, I said earlier, GraphQL is not just an external thing. It's an everywhere thing. So there's been times where, of course, you're on a network and you're funneling all your traffic and your web traffic through maybe a NUC or a device, or you're VPN into the network, however the client wants you to do it. And now you run across a GraphQL API internally. Even if they have introspection disabled, you can still get the schema, doesn't matter. Once you get that and you see maybe, like, I will always try system debug, because a lot of times that's actually worked for me more than once. So I'd recommend trying that first as an option. If you see you have access to that and you're looking for like command injection, that would be the route to go to. Now, once you have command injection internally, I can't show the 80 stuff here, but there have been instances where I've seen like 1 or 2 Linux boxes that were connected to the domain controller. Didn't get me much, but it got me just enough where the client was kind of concerned, like, why is this even a thing? And they didn't even know that this was even enabled on the actual box. So definitely when you're checking for command injection, this is what you want to look for, right? Now, same concept applies when you're doing SQL injection. Then there's many other commands that there's many other attacks that you can do. It's just that kind of had to cut down a lot of attacks due to time as well too. So in this case, we're gonna go right to some more command injection. Now this time I wanted to see if I can get access to a password. Let's see what's actually on that particular Linux box. So this is another thing, and literally I just pretty much just appended the command, looked at the password file, and voila. And this is just all through the application. Now, what would make this worse is, say if this was a public-facing healthcare website. Say if this was something like with healthcare, or a hospital was running this, right? Now we really got a problem, because now I have access to one of your Linux boxes, have command injection. I'm free to run commands, and depending on the permissions of that particular account, can be detrimental as well too. So these are things that you definitely want to, when you're testing, you definitely want to look out, make sure that your client is aware of that as well too, because yeah, not only will you save their situation, but you know, yeah, I'll leave it at that. But now you can also do GraphQL. You can do SQL injection with GraphQL, which is no surprise really, because it is a query language. So a lot of times, a lot of developers configure it for the actual database, mainly NoSQL. I've run into NoSQL. Rarely you get SQL injection, because a lot of people are using MongoDB at the most. And again, I like to come back to my favorite spot. This is my sweet spot, my Voyager, my GraphHound, my everything. So now I'm looking at this, I'm like, okay, let's see what we got here. What queries, what can I do to do like SQL injection? I've already got command injection in system debug. So I'm like, okay, what does paste do? And the reason and this application just happened to have paste, because this is just a sample application. But if it had any other query, you notice like with query paste, it looks at like the Boolean. That was kind of a dead giveaway for me as well too. Like saying, okay, cool. If I'm seeing like a Boolean, I'm like, okay, it's connected to some type of database or whatnot, right? If I'm looking at like the user agent, IP address, definitely the object ID. And another dead giveaway for me too was the owner object, a foreign ID, right? So that was another giveaway as well too that made me think, okay, and this is something you can use as well too if you're testing for SQL injection. If Voyager is showing that it's pointing to maybe like a foreign object ID, pretty much is connecting to some type of database and extracting the database information to get back to you that way as well too. So knowing that, now we fire up our good old burp, and I recommend understanding, and this is why I said it's good to understand how GraphQL works, because pretty much you can write any query to get any information. It's no different than when you're learning SQL to do SQL injection. The more you learn about GraphQL, the more dangerous you can become, the more information that you can extract, the more things that you will find. In this case, with this particular query, I just pretty much just used the object. I just pretty much threw a filter in there, and then just, of course, I like my favorite word, bandit, and pretty much I needed to add extra quotes to this to make sure that the query would run or give me some type of error message back. In this case, it's SQLite. Now that you got this information, now you know that it's vulnerable to some type of SQL injection, then you can fire up you have your options from there. You can either manually start throwing queries at it. You can fire up dear old, good old SQL mapper, which can save you a lot of time as well too, and get you more information and bring you a little bit further into the network. These are the particular attacks that I have here today, but you can also start looking for information disclosure. You can also do traversal networking through the network as well too. So these are things that you can actually look for, because a lot of the GraphQL environments are connected to some type of network, some type of application is connected to something else. And then a lot of times the GraphQL APIs talk to each other, not just an app. So now you're going down many different avenues. Because again, as I said earlier, 90% of the internet traffic that we're dealing with today is some type of API call, whether it's your phone, whether it's your car. As we go more into the electric car phase, I mean, that's all just like APIs all over the place. Shoot, the way it's going, we might be walking APIs with all the phones and everything that we have on us. Yeah. So that is my presentation. Ow! Yep.